Hello everyone. I would like to perform a capacitors problem that shows multiple capacitors in both parallel and in series, and we'll have to add them up to find the equivalent capacitance between the left-hand point A and the right-hand point B for the combination of capacitors shown here. Now, in order to accomplish this problem, we should know how to add capacitors in parallel and in series. In parallel, they sum in a traditional way, and with capacitors in series, we use the reciprocal rule. Now, we want to start with the innermost combination of capacitors. So we can either start with this parallel arrangement, or we can start with this series arrangement. But either way, we need to start most inner. So I'm going to suggest we get the capacitance of capacitors 3, 4, and 5 first. So let us write that the capacitance of 3, 4, and 5 is equal to capacitance 3 plus capacitance 4 plus capacitance 5. So that should be, let's see, 1 plus 6 plus 2 in microfarads. 1 plus 6 plus 2, all in microfarads. Okay? And then let's just calculate this entire problem in microfarads. So the capacitance of 3, 4, 5 together, because they're all in parallel, they all act independently, is going to be 9 microfarads. Okay, fine. Now, capacitors C2 and C6 are in series to each other. So what we should do there is we should say 1 over the capacitance of 2 and 6 put together is equal to, let me section this off, 1 over capacitance 2 plus 1 over capacitance 6, because we use the reciprocal rule. So what we should do is we should say 1 over, now C2 is 4 microfarads, plus 1 over 8 microfarads, and then let's go ahead and get a common denominator. So the common denominator, which is the least common denominator, is going to be 8, multiplying this fraction by 2 over 2. So we'll have 2 over 8 plus 1 over 8, and that's 3 over 8. And remember, that equals 1 over C2, 6. So as a result, C2, 6 should be 8 over 3 microfarads. Okay? So now we have the equivalent capacitance of these. Now let me go ahead and redraw the capacitor assembly at this point. So now we have here point A, and then we have this capacitor, okay, C1, and then we have this equivalent capacitor, the C2, 6 capacitor. Then we have down here to point B, and on the other side we have another capacitor, which is the C3, 4, 5. So this is C3, 4, 5. All right. Now, with that in mind, we can say, okay, C2, 6 and C3, 4, 5 are just in parallel to each other. So we should just add these numbers that we just came up with. So that means C2 to 6, that is adding all capacitors from 2 through 6 together, is going to be the sum of 9 microfarads plus 8 over 3 microfarads. So we should get a common denominator again. This is 27 over 3 microfarads plus 8 over 3 microfarads, and that's 35 over 3 microfarads. Okay? By the way, just as an internal check, we can say that the C345 capacitance should have been 9 microfarads because that's larger than 1 or 6 or 2. The 8/3 microfarads, that's the same thing about 2.6 repeating, but that is less than either 4 or 8. But then 35 over 3 is larger than 9 or 8/3. Now finally, what we can say is we can say that we want to, so now these capacitors have been added together as one single capacitor. So then that's going to be in series with capacitor C1. So we can just write that C1, which is, by the way, C1, or not C1, it's going to be the equivalent capacitance of all the capacitors. It's going to be C1 plus everything 2 through 6 is going to be 1 over C1 plus 1 over C2 to 6, and then let us reciprocate this. This is another way to perform the reciprocal rule. Add up the reciprocals, then take the reciprocal to get the equivalent capacitance. So 1 over C1 is just going to be 1 over 1, and then plus 1 over C2 to 6. Now, this is a fraction. If you put it below, dividing by a fraction is the same thing as multiplying by the reciprocal. So that's going to be 3 over 35. Well, we should get this in 35ths. And don't forget to have the reciprocal on this. So this is 35 over 35 plus 3 over 35. And the reciprocal of this number is going to be 38 over 35. So I'll just write that down. That's 38 over 35 with a reciprocal. And that should be 35 over 38 microfarads. And that should hopefully be our final answer. Okay. Now, by the way, you may ask, what is that as a decimal? Is approximately, to 3 decimal places, 0.921? 0.921 microfarads. And then clearly 0.921, or 35 over 38, is less than 1 microfarad. Because remember, when using the reciprocal rule, the resulting capacitance needs to be smaller than the smallest capacitance of capacitors that are added. So it has to be less than 1, which it is. Okay, that concludes this problem. Thank you very much for your attention. Please like, comment, or subscribe. And thank you for your attention. I will see you in the next video.